Hello everyone. Today I'm going to develop InceptionV3 on binary classification using TensorFlow and Keras. InceptionV3 was developed by Google research team. It focuses on efficient computation and high accuracy through innovations like inception module, factorization convolution, and auxiliary classifiers. In this tutorial, we are going through the following steps: installing necessary packages, loading the dataset, splitting the data into training, test, and validation sets. We are going to train our model on the training set, validate our model on the validation dataset, and finally, we will test our accuracy on the test set. We will learn plotting the accuracy and loss graphs, testing our model on some sample. We will see some, we will test our some sample test data. After finishing the training, we will learn how we can save this model and load this model for future use. About me, I'm Dr. Noman, PhD from Edith Cowan University, Australia. Before beginning, if you are not familiar with the, the Python environment or configuring your computer for this project, I can recommend you can check out my first video where I explained in detail how you can create this one. This link is available in the video description section. Now let's get started. So these all are the packages we need for this InceptionV3 model training on binary classification tasks. So now I am going to importing all these packages. So these are the image size 299 and 299. So we are going to resize all of our training, test, and validation images by 299 by 299. This image size is standard for the InceptionV3 model. Now we are going to load InceptionV3 model with pre-trained ImageNet weights. So we are going to do the transfer learning here and including topical equal false because we are adding some extra layer for the binary classification. We are in the top, we are adding some binary layer for the classification. So here we are going to load our model. So we are freeze the base model layer because we are going to use as a feature extractor, and it will prevent our pre-trained weight to be training during initial training. So we are going to freeze all of our base model layer. This is the folder structure. You can see this is cats and dogs, training. If you see the training folder, you can see it has the cats and dog images. Here we are adding extra layers because we are going to do the binary classification task. It has for dense layers, finally it will be 1, and we are going to activation function is sigmoid. And finally, we are defining our model here because with the base layer and with and plus some additional layers, we are defining the model. So after defining the model, we are going to compile the model here. So compilation is we are using Adam optimizer with learning rate 0.0001 with binary cross entropy loss function and matrix is accuracy. So now we are going to uh, do some data augmentation. So it will give more uh, more training sample in for the model. So we are going rescaling. So all of our pixel is in between 0 to 1, rotation, shifting, zooming. So all of this horizontal flipping, we can do vertical flipping as well. So this all are the data augmentation. It is good for making more good model. So we are creating the validation data generator as well and test data generator. Now we are uploading our data. So we have 204 images into 2 classes, and validation we have 81 images into 2 classes, and test as 131. Just I made it random data set. You can train this model on your own data set. Now I'm going to train this model on 100 epochs, so it will take time. So now I started and see, it is uh, it starts the training. So now we can see accuracy is very good. I like this model because it has a very good accuracy and it's very quick. So after first epochs, we can see it's like a 77% training accuracy and loss is 0.04, 0.4, and validation accuracy 98%, and validation loss is very less, like a 0.01. So after two epochs, it is 97% accuracy and loss is like a very much decrease here, and 0.08, and validation accuracy 100% accuracy and validation loss is 0.02. So now I'm going to pause the video, wait until it finish 100 epochs. So now we can see it finished 100 epochs. So it has a very good accuracy, like 100% training accuracy, and loss is very less, and validation accuracy 100%, and loss is like very less, like 0.0019. So it is a very good model. I like this model very much. So now we're going to see the whole model. So this is like whole inception model. Here, what are the batch normalization, activation, convolution, every layer it is here. So we can print and see, and we added like a last two layers for our binary classification tags. So it's like a very big model and very good model. So you can see everything from here, and it is like a dense layer I put, and we are flatten all layer, and this layer I put like a one, and we're going to classify binary. So now we can test our model on test set and see how much accuracy it can give on the test data sets. So it's 98% accuracy. So it's 96% test accuracy, and loss is 0.14. It's like a very good accuracy because you need more training sample to get more accurate model. Now I am going to plot my uh, accuracy graph and loss graph. So accuracy graph is so it's like a very good. It's like almost 100%. It's like a accuracy graph. Now going to plot the loss graph. Yeah, it's less. It's very less, like almost zero. So like validation and training loss is almost zero. So now I'm going to save our model in say Inception V3. Inception V3, and we need to load our model. So it will save Inception V3, and we are going to load this model. Yeah, we loaded, and we want to see the saved model. We are not using the model. We are going to use this loaded model as a saved model. I'm going to test some testing data, like what it will give, so how it can predict correctly or not. Some sample test data, we are going to see our saved model can predict correctly or not. So it is dog, 100% confident that it is dog. So it's like a very good. So now we can see number one images. So some in the testing folder, I put some 3 images to see how it can predict correctly or not. Yeah, it's like 100% confident it is cat. Number two, we can check that number two. Yeah, it's like every image is like 100% confident that it's like cats or dogs. It's like a very good model. And so now uh, time to thank you for watching my video. So thank you for watching my video. If you like it, please hit on the like button, share my videos, and subscribe. Thank you, everyone. See you on next video.